Hi, welcome. I know why you're here, and it's not to learn calculus, it's to join me in the simultaneous sip. So if you have your coffee ready, please join me. The question we're working on today is, find the local maximum and minimum values of the function f of x equals 3 times the cubed root of x minus x. Okay, so we'll start this question by first writing down the function. So we have f of x is equal to 3 times x to the 1/3 minus x. And so the question is, find the local maximum and local minimum values. So the way we do that is we have to first find the critical numbers. So to do that, we take the derivative, f prime of x is equal to 3 times 1/3 x to the 2/3, x to the negative 2/3, so that's x to the negative 2/3 minus 1. Okay, and now we want to find where this function is either equal to 0 or it doesn't exist. And so it might be best to clean up the derivative first before we try to figure that out. So we could rewrite this as 1 over x to the 2/3 minus 1. And now we could get a common denominator. And we see that this is equal to 1 minus x to the 2/3 over x to the 2/3. So the question becomes, when is this equal to 0? And for what values of x does this not exist? And that's what we'll work on now. So maybe pause the video and see if you could solve it. So we'll start by looking for when f prime of x equals 0. And since f prime of x is a fraction is equal to 0 when its numerator is equal to 0. So we have 1 minus x to the 2/3 is equal to 0. And so this is the same as 1 is equal to x to the 2/3. We could raise each side to the 3/2 power. And we get that x is equal to 1 or negative 1. Now we can look for when f prime of x does not exist. And that happens when the denominator is equal to 0. And so for what value of x is x to the 2/3 equals 0? Well, that's just x equals 0. So what we'll do now is we'll draw a number line. And we'll break it up at each of our critical numbers. So negative 1, 0, and 1. And we need a test value in each of these segments. Because what we want to do is we're going to test to see if the derivative is positive or negative in each of these segments. And from that information, we could find the locations of the local maximums and local mins. So our test values could be negative 2, negative 1/2, positive 1/2, and positive 2. So we want to find the sign of f prime of negative 2. Well, that's equal to 1 minus negative 2 to the 2/3 over negative 2 to the 2/3. 1 minus negative 2 to the 2/3 is a negative number, and the denominator is positive. So a negative divided by a positive is negative. So we'll have a negative derivative on this part of the number line. And then we could continue this, testing the other values. And if we were to plug in negative 1/2 into the derivative, we'd get a positive. if you were to plug in positive 1/2 into the derivative, you would also get a positive. So we get positive, positive. And if we were to plug in 2 in for x in the derivative, we would get a negative. So the first derivative test says that there is a local max whenever our derivative goes from positive to negative. So we have a local max at x equals 1. And the point of that local max is 1 comma f of 1, which is the point 1 comma 2. Okay? And now, again, the first derivative test says there's a local min whenever our derivative goes from negative to positive, and our derivative goes from negative to positive at x equals negative 1. So local min at x equals negative 1, and the point, that's at the point negative 1 comma f of negative 1, which is the point negative 1 comma negative 2. Okay, so we have, just to recap, we have a local max at the point 1, 2, and a local min at the point negative 1, negative 2. Well, thanks for stopping by. I'll see you next time. Don't text and drive. Bye-bye.